afternoon friends. As you are aware, in previous class we discussed different types of probabilities and we have worked out couple of examples as well. In today's session we are going to talk about probability distributions. So, largely you have got two types of probability distributions. You have got discrete and continuous, and in discrete distributions you have got again different types of discrete distribution, and in continuous as well there are different types of distributions. So, let us start with this particular topic which is on discrete probability distributions. So, we will see different types of discrete probability distributions apart from definition of random variables to different types of discrete distributions like binomial, Poisson, hypergeometric distribution. So, let us look at couple of definitions. Random variable is numerical description of the outcome of an experiment. So, if someone asks you what is a random variable, then you can say that random variable is a variable which is in which a variable can take any random value as an output of any experiment. So, just to give you an example, let us say if you throw a die. So, what is the probability that on surface 5 dots appear? Now, it is just 1 by 6, right, and we do not know how many dots will appear. So, either 1, 2, 3, 4 or 4, 5 or 6, right. So, it may take any value, right. So, you can have again discrete random variable and continuous random variable. So, a discrete variable may assume either a finite number or infinite number. So, if there is an upper limit, then we will say it is a finite discrete random variable, otherwise infinite. Okay. And you can have a continuous random variable as well, where any numerical value is value in an interval or collection of intervals. So, that is a continuous random variable. We will see more these definitions in detail. So, let us look at what is a discrete random variable which is finite. Now, in this case, as I said, it is finite. So, it is infinite, right. So, finite means there is some upper limit. So, let us say x number of TV sold at a store in one day. So, you will have some number, right, 1, 2, 3, 100, 200, 500 and so on, right. So, that is finite. Let us say number of homes in a city, let us say you can have 500 homes, 600 homes, 651 and so on, right. So, there is a finite number of values. Okay. So, let us say a number of pet animals in a house, it can be 1, 2, 3, is not it. So, it would be a finite. When I say infinite, so let us say number of customers arriving in one day at a TV shop. So, x can take value 1, 0, 1, 2, 3 and so on, right. So, there is no upper limit. So, we will call it infinite, is not it. So, this is a case of discrete random variable which is infinite. Let us look at this example. So, family size is what type of variable? It is a finite or infinite. So, number of dependents reported on tax return. So, can you have this infinite, or first of all you tell me whether it is a discrete or continuous, right. So, this is basically a discrete type, right. Distance in miles from home to store site. Now the distance can have some non-integer value as well, right. So, distance can be 30.33 kilometers, is not it. So, this is not a discrete, right. Or let us say the number of dogs or cats owned by a family, right. So, one pet, right, 2 dogs, 3 cats and so on. So, what is this again, a continuous or discrete? It has to be a discrete one, right. So, let us look at probability distribution. What is probability distribution? Probability distribution is basically a representation of probabilities of some variable. So, how probabilities are distributed over values of some random variable. Let me give you an example. Let us say you are contesting for an election, and let us say there are 10,000 voters in that particular city or in that particular district. Okay. So, the total number of voters are 10,000. Now, you want to know how many votes you would get and the probabilities associated with those number of votes. So, let us say these are number of votes on x axis, right, on y axis you got probabilities, right. Okay. So, let us say you will get 2000 votes and its probability is 0.10. You will get, let us say 6000 votes, its probability is 0.50, and let us say you will get 10,000 votes, its probability is 0.40. So, this is nothing but a probability distribution. Okay. Keep in mind that the sum of these probabilities should be 1. In this case 0.5, 0.4 and 0.1, this is equal to 1. So, we can describe a discrete probability distribution with a table, graph or equation, right. So, this is a graph, is not it. The probability distribution is defined by a probability function. So, you can denote it by f of x, which provides the probability for each value of selected random variable. So, it can be either 0 or more than 0 or equal to 1, but it can never be less than 1. Okay. Let us look at this example. So, there is a TV retail outlet, and the owner of the shop has collected some data over number of days, the number of units the number of TV units sold, right. So, the shop owner collected data of last 200 days, and he found that on 80 days the number of units sold were 0. On 20 days he sold 4 number of units. So, this is x, number of units sold, and f of x can be calculated by just dividing this 80 by this total number of days. So, this is 0.40 is the f of x. Similarly, 0.25, 0.20, 0.05 and 0.10. So, this total has to be 1, right. So, this is nothing but a probability distribution, right. So, what is the probability that 0 unit of TV sold was 40%, right, and so on. So, the same information can be put in this graphical representation form. So, 0 unit of TV sold 0.40, then 1 unit, you can see in previous slide, for 1 unit it is 25%, for 4 units it is 10%, right. So, you can see all these values, right. For 4 units it is 10%, right. So, this is nothing but a probability distribution, a discrete probability distribution. So, let us look at uniform probability distribution. A uniform probability distribution is simplest of the discrete probability distributions. So, this is how you represent uniform probability distribution. F of x is equal to 1 by n. Here n is the value of random variables which are equally likely. Okay. So, let us take an example. So, you want to know the number of dots on upside when you roll a die. So, f of x is 1 by n, is not it. So, n can be either 1, 2, 3, 4 or 5 or 6, right. So, there are 6 possibilities, right. So, this 1 by 6. So, you can get one dot, its probability is 1 by 6. Again you will get 6 dots on its surface, again it is 1 by 6, right. So, this is nothing but uniform distribution. Let us look at expected value and variance. Expected value is nothing but it is a mean value of a random variable which measures central tendency. So, this is E of x, E stands for expected value, is equal to mean, and this is E of x summation of x into f x, and variance is this the variance. So, x minus mu whole square multiplied by f of x, and what is mu? Mu is mean, right. So, once you know variance, you can easily calculate standard deviation, right. Take positive square root of variance. So, we will calculate all these values. So, for the same example, right. So, this is what we have seen our example. So, f of x is given for these number of units sold, and this total is 1, right, is not it. So, x into f of x is 0, 0.25, 0.40 and so on, right. So, this total is 1.20, right. So, this is the mean value, right, 1.20, right. So, once mean is calculated, you can easily calculate variance and standard deviation. So, this is mean is given, right, you calculated in previous slide, which was what, 1.20, right. So, 0 minus 1.20 is minus 1.20, 4 minus 1.20 which is 2.8, right. So, take square of this, f of x is known, multiply these two and take summation of this. So, the variance of daily TV sales is 1.66. So, we are saying that the mean is 1.20, variance is, mean is this, variance is 1.66, and if you know variance, you just take positive under root of it, right. So, this would become 1.28, is not it. So, this is nothing but standard deviation. So, this is a situation where standard deviation is more than mean. Okay. So, this is expected value and variance. Now, let us look at another type of discrete probability distribution. So, we have seen one which was uniform, the second one is binomial distribution. Now, binomial distribution is a discrete one and it is not a continuous one. So, the data resulting from an experiment is known as Bernoulli process, and there are certain properties of binomial experiment. So, these are the properties. So, the first is the experiment consists of a sequence of n identical trials, and there would be always two outcomes of an experiment. So, when you throw a fair coin, you will always have two outcomes, right. So, throwing of a fair coin is nothing but a Bernoulli process, right, because it has got only 2 outcomes. So, the outcomes cannot be more than 2, that is the property of this. So, you can have outcome as let us say success, failure. Now, what about throwing of a die? Is that an example of this? No, that is not an example of this. So, you will always have 2 outcomes whenever there is a trial, right. The probability of success denoted by P does not change, it remains fixed. So, when you throw a die, the probability of success is always 0.5. So, now the success can be either heads or tails, right. So, this is the second, the third probability, right. So, this is Bernoulli process. And what is binomial distribution? It is a discrete one, and it represents data which are output of a Bernoulli process, and the trials are independent. This is the fourth condition, because if you toss a fair coin first time, let us say you are getting heads, right. Second trial you do not know, you may get heads or tails, right. So, the second trial is independent of first. So, the trials are independent of each other. So, what we want in binomial distribution is, we want to know how many successes in n number of trials. So, it is let us say either you call it NCR, or you can have it NCX, whatever you want, right. So, let x denotes the number of successes occurring in n trials, right. So, let us say if you toss a coin for 15 times, what is the probability that 3 times you will get heads, right. So, binomial probability function is this, it is very simple. This is factorial n divided by factorial x n minus x, right, is not it, p to the power x q to the power n minus x, right, is not it, a very simple formula. So, this is how you can have formula like this. So, this portion is nothing but the number of experimental outcomes providing exactly x successes in n trials, right, and this is probability of a particular sequence of trial outcomes with x successes in n trials, right. So, let us look at one question which is related on binomial distribution. So, there is a firm called Evans Electronics, and this firm is facing a problem of retaining employees, and over the past few years experience, the management has seen that turnover is 10% of hourly employees. So, let us say in the beginning of the year there are 100 employees, then by the beginning of next year there will be only 90 employees, right. So, that is turnover rate. So, thus for an hourly employee chosen at random, so suppose if you choose an employee at random, management estimates a probability of 10%, right. So, that a person will not be with the company next year, is not it, that is the meaning of 10% turnover rate. Now, if you choose 3 hourly employees at random who are working with the Evans Electronics, what is the probability that one of them will leave the company? So, it is a case of 3 C 1, right, is not it. So, you just put, and we know what is P is 0.10, right. So, you can put those values over here. So, P is known, N is known, X is known. So, you just put this value. So, the probability that if you, out of 3, 1 hourly employee will leave is 0.243 or 24.3%, right. So, if you do not want to use this formula, then you can solve this question using tables as well. So, if you look at any good book of on statistics, you will always have binomial table, and this table gives you answer directly. So, we know that n is equal to 3 in our question, in our example. We wanted to know what is the probability that one of them will leave the job. So, this n, this x. So, probability that one will leave job, nobody will leave job is this. Probability that one will leave job is this, is not it? Probability that 3 will leave job is this. So, let us say if I ask you a question, let us say n is equal to 3, x is equal to 2 and p is equal to 0.50. So, what is the probability that out of 3, 2 people will leave the job, given that p is 0.50. So, it would be what? So, this is n is equal to 3, x is equal to 2. So, you have to look at here. So, this is the answer. So, you can put these values in either that formula, or you can directly get it from table. So, this is binomial distribution. Okay. So, keep in mind that its properties are there are only 2 outputs, right, and the trials are independent. These 2 are important characteristics. Let us look at what is the mean and variance of binomial distribution. We have seen mean, variance and standard deviation of uniform distribution. So, its mean is simple, is NP, right. This variance is NPQ, right. This Q is nothing but 1 minus P, is not it? And of course, once variance is known, standard deviation can be calculated, right. So, this is very simple, it is NP, NPQ, right. So, mean for that example is this is the example wherein the expected value or mean is 3, right. So, we are doing this we are solving same example, Evon electrical example, right, Evon electronics example, right. So, once you know mean, you can calculate variance and standard deviation, right. So, this is how you can calculate mean and standard deviation of binomial distribution. Now, let us look at Poisson distribution. Poisson distribution is another type of probability distribution, which we use to describe several processes. For example, the distribution of phone calls going throughout a switchboard system, right. So, let us say there is a firm and there are thousands of employees. So, what is the probability that at a particular given point of time 50 people make phone calls, right, or the demand of patients for service in a hospital, right, or let us say arrival of trucks or cars at a toll booth, or the number of accidents taking place at an intersection, right. So, this is an intersection. So, this one road, second road and this So, what is the probability that an accident will take place over here, right. So, this is Poisson distribution. So, and these are the processes which describe Poisson distribution. So, here the random variable is often useful in estimating the number of occurrences over a specified interval of time or space or area, right. So, you can always find out, let us say, what is the probability that mosquito will bite you on your right hand, is not it. So, in a given particular area you will be finding probability of happening of an event. So, it is a discrete distribution. So, random variable may assume an infinite sequence of values, let us say 0 to infinite, right. let us look at this example. These are couple of examples. So, let us say the number of knot holes in 14 linear feet of pine board, right. So, these are nothing but knot holes, right, is not it. So, you may have different number of knot holes on a particular area of any let us say any tree, right. So, the number of vehicles arriving at a booth we have already seen, is not it. So, these are a couple of examples, right. Similar to what we have seen in case of binomial distribution, there are certain characteristics of Poisson distribution as well. So, the mean number of vehicles that arrive per rush hour can be estimated from past data. So, let us say this is your road and you have got a toll booth over here, right. So, these are the vehicles coming, right. So, you know from past data how many vehicles generally come during one particular hour. Okay. So, we can calculate mean number of vehicles which are arriving during one particular hour of a day, and that can be estimated from past data, right. So, if we divide rush hour into periods or equal intervals of 1 second each, we will find these estimates true. The following statements which are there in next slide true. And what are those statements? So, what we are saying, let us say if you have got 1 hour's time, right, 1 hour time, right, then you can divide it into let us say 60 equal parts. Okay. So, the probability that exactly one vehicle will arrive at a single booth per second is very small number and is constant for every 1 second. So, let us say this is your 1 hour period. So, let us say this is first minute, second minute and so on, right. So, this is your 60th minute, right. So, according to this, probability that exactly one vehicle coming in first minute is a small number, right? So, its probability is very small, and that probability will remain same in all these intervals, and it is very small, and it can be, and it is a constant, right, for every 1 second interval. And the probability of 2 or more vehicles coming in each of these intervals or this 1 second period is such a small value that you can keep it 0, is not it. So, let us say this again first minute, second minute and so on. So, this is your 60th minute. So, probability that 2 vehicles first, second and more than 2 vehicles coming in this interval, that probability is can be assigned equal to 0 value, and the number of arrivals in any 1 second is independent of number of arrivals in any other second. So, number of arrivals which are the number of vehicles coming over here are independent of number of vehicles coming in this interval, right. So, that is independent, right. Poisson probability distribution is this. So, it is f of x is equal to mu to the power x e to the power minus mu, which is mean, right, and factorial x. So, f x is probability of x occurrence in an interval, this mean, and this is e value 2.71, right. So, mean number of occurrence keep in mind this is mean value, right. Okay. So, let us take this example. So, in an hour let us say let us say this first minute, this is let us say 15th minute, this 45th minute and this is 60th minute. So, let us say you are getting 1 vehicle over here, 1 vehicle here, 3 here, 5 here, again 1 here, right. So, this mean is the mean number of vehicles coming per hour. So, what would be the mean? So, 1 plus 3 4, 4, 5, 9 and 10. So, we will say 10 vehicles per hour. Okay. So, let us say in a day, let us say in an 8 hours day you are getting 40 vehicles. So, how many per hour? It is 5 per hour, is not it? So, that is how you should calculate mean number of occurrences of an interval. So, before going on to example on Poisson distribution, let me summarize what we have done today. Today we have seen probability distribution and we have defined what is random variable. A variable which can take any value which as an output of an experiment. Okay. So, if you toss a fair coin, it may take either heads or tails. So, it is random, you do not know what it will, what will be the output, right. Then we have seen different types of distributions. We have seen uniform distribution, we have seen binomial distribution, we have seen Poisson distribution, and we have seen uniform distribution. So, the simplest of all these distributions so far was uniform distribution, because the f of x was just 1 by n, right. And binomial distribution is again a discrete one, and you need to ensure that in binomial distribution you are following Bernoulli's characteristics, right, characteristics of Bernoulli's process, right. And then Poisson distribution, which again use which is again useful for describing several processes. For example, the number of accidents taking place at an intersection, number of vehicles coming at a toll booth, and so on. So, with this let me finish today's session. We will have a couple of examples on Poisson distribution in next session, and we will also see continuous distribution in next class. Thank you very much.